Alright, in this section we're going to talk about angles and radian measure. And angles in standard position if its vertex is the origin, which remember the origin is here, and its initial side lies on the positive x-axis. So let's say this is our initial side, and we're going to say this is our terminal side. So let's just label those real quick. Terminal means where it stops, so our initial side and our terminal side, this is angle theta, and we said the vertex is the origin. Right there at 0, 0. Okay, so now we're going to make the comment that rotation counterclockwise will be a positive angle. So when we're going in this direction, we're going to get a positive angle. So let's make that note. Result in a positive angle. Let's see, let me use a different color. This is my initial side, and this is my terminal, and I'm going in this direction. If I go in a clockwise direction, I will get a negative angle. So if this is theta, then that would give me a negative angle. So I'm going to make that comment to the side as well. Okay, and so we can see this would, if we start here and we terminate on this side, we go counterclockwise. This is a positive angle theta. If we start here and we go clockwise, it's going to be a negative angle theta. Also, I want to make a comment about a quadrantal angle. Let me just sketch another one. So if I start on my initial side, and then if I have an angle that, let's say, I'm going around, and let's say it terminates here. So this angle theta from here to here is going to be a quadrantal angle. So basically, if it starts on the initial side and our terminal side lies on one of the axis, then it's going to be a quadrantal angle. So let's make a comment about that. And so we define that there. Okay, there's two ways to measure angles. It's going to be in degrees, which most of you like best, and then there's radians. Okay, let's just recall some geometry facts. So if we have an acute angle, that's going to be what? Less than 90 degrees. Good. Okay, and then if I have an obtuse angle, it's going to be what? Well, it's going to be greater than 90 but less than 180. Actually, let me put the degrees in there. Greater than 90 but less than 180. Let's recall what a right angle is. Need those. A right angle is going to be just 90 degrees, and then our last one is a straight angle, which is what? 180, right? Okay, so if I have to the left, let's say this is 0 degrees, what is this first one? This one here. 90 degrees, and then here is going to be 180 degrees, right? It's our straight angle. So, and then what does that make this? 270. And then also 0 is the same as 360 if you make one revolution all the way around. So let's look at radian measure. So that's degree, which is pretty intuitive for us. And now we look at a radian measure of any central angle is the length of the intercepted arc S divided by the radius, by the circle's radius. So let me just draw a picture real quick. Okay, with this labeled now, we can see that this is our radius from the origin to here. So this R represents our radius. This is angle theta, and this S is considered the arc length. Okay, and we know that theta, here's our theta is defined by S over R. 1 radian, the measure of the central angle of a circle that intercepts an arc length equal to the length of the radius of the circle. Okay, that's just when S is equal to R, it's the equivalent to 1 radian. Okay, so we're still gathering facts so we can get to the point we can see how all this comes to play when we get to our unit circle. Alright, so the radian measure. So let's recall from the last. First of all, if I have this circle, let's just recall some things. What is 1 rotation all the way around? 1 rotation, good. Let's just jot down some basic things that we know. 1 rotation is 360. So what does that tell us about S, our arc length? So if I'm going around, all the way around, all the way around, what is our arc length equal to? It's 360. It's still all the way around, right? So it's all the way back around. All right. Now, what about circumference of a circle? Let's just recall all kind of facts that you've known prior to this. What is the circumference, the formula for the circumference of a circle? Right? Circumference of the circle describes exactly this. So let's just say it in terms of circumference. Circumference is defined by 2 pi r, right? Okay, so I'm just going to say now we're looking at it in terms of that. The other piece of information that we have is from the previous page. Let me step back over here. Is this information. We know how theta is defined in terms of arc length and radius. So I also have this information. Theta is equal to S divided by R. Okay, well if that's the case, and I say, well theta, what did we just define S as over here? Right? 2 pi r. So if we have 2 pi r, we're trying to determine the relationship between previous things we know and how radian measure comes about. So just hang in there with me. So we said, okay, well S is the same thing as 2 pi r. Let me make this r a little better. So I have my S, and then let me put that back over r, and then what happens algebraically? Good, the r's cancel, so what we find out is that theta is equal to 2 pi. Okay, so 2 pi radians is equal to 360 degrees. Okay, well then what does that make pi radians equal to? Let's just keep doing some algebra here. What would pi radians equal? Well, if 2 pi is 360, what's only 1 pi? Good, good, good. So 180 degrees. So what we're figuring out is basically this is our relationship to be able to convert degrees to radians. And in a lot of cases, you're just given the formula. Bam. Here's what you do to get from degrees to radians, and here's the rule that you use to convert from radians to degrees. But what we just did is we saw why we do that. Where does that relationship come from? And so that now that we've done that, we won't have to do that anymore. Now I'm just going to say to convert degrees to radians, multiply by pi over 180. Okay, and let's see an example of that. So if I give you 30 degrees, I want you to take 30 degrees and convert it to radians. So our tool is we want to go from degrees to radians. We said multiply by pi over 180. And then you're just simply going to multiply across, and you can reduce these in your head if you prefer. The more you do these, the better you'll get. So what's that simplify to? Good, so it's just pi over 6. So 30 degrees is equivalent to pi over 6 in radians. And now also we have the rule to convert from radians to degrees. We multiply by the reciprocal of the other one, so 180 over pi. Okay, so this time I'm going to give you a radian, pi thirds, and I'm going to ask you to convert it to degrees. So we multiply by 180 over pi. And the nice thing is the pi's cancel typically, so you get 180 divided by 3, which is 60 degrees. So from now on, we're going to use these two, the relationship with these rules, to be able to convert from degrees to radians and vice versa.